A hidden map connects the world's ancient wonders. The pyramids, Stonehenge, and temples across the globe may be precise points on a single prehistoric blueprint. Ancient civilizations appear to have possessed a lost science of global geography, embedding advanced astronomical and geodetic knowledge directly into the placement of their monuments. By the end of this journey, you will see the ancient world through an entirely new lens, one where space and time are woven into the landscape itself. How could cultures separated by oceans share the same mathematical constants? What grand purpose did this planetary scale design truly serve? What does it mean to discover that our deepest history might be written in the language of latitude and longitude? Geodetic alignment is the art of building by the blueprint of the planet itself. It is a practice that treats the Earth not as a flat expanse, but as a measured sphere, and structures become precise pins placed upon its curved surface. This concept moves us far beyond appreciating a monument's beauty or even its astronomical purpose. It asks us to see these sites as permanent survey markers, anchored with intention to specific points of latitude and longitude. The builders, it seems, were not just constructing for their own time. They were etching a message into the geography for the ages, using the land as their parchment and stone as their ink. To achieve this, they would have required a lost science of global measurement, a way to understand the Earth's dimensions and translate that knowledge across vast, trackless distances. How do we begin to see this hidden layer? We start by shifting our perspective from the ground to the sky and back to the ground again. Ancient architects often began their work by observing the heavens, charting the paths of the sun, moon, and stars. But here is the crucial step. They then projected those celestial patterns down onto the landscape. A solstice sunrise alignment at one temple might not just mark a sacred day, it could also define a specific directional line that, when extended across continents, points unerringly toward another sacred site. This creates a network, a web of intentional connections where geography and cosmology become one and the same. Scholars like John Mitchell and Jean-Pierre Houdin have spent decades tracing these lines, arguing that the mathematical constants and geometric principles found in these layouts reveal a sophisticated understanding of spherical geometry, a science historians often attribute to much later civilizations. Why go to such extraordinary lengths? The motivation was likely profound. In the ancient worldview, the earthly and the divine were not separate realms, they were reflections of one another. A temple was a microcosm of the universe, and by placing it correctly upon the Earth's body, the builders believed they were harmonizing human creation with cosmic order. They were building a bridge between worlds, and the foundation of that bridge was the very shape of our planet. This foundational idea transforms every ancient site from an isolated wonder into a potential node in a global network, setting the stage for the breathtaking patterns we are about to uncover. To test this idea of a planetary blueprint, we must begin at a place of undeniable power and precision. The Giza Plateau in Egypt does not merely host the last surviving wonder of the ancient world. It presents us with a mathematical riddle carved in limestone. The Great Pyramid sits at a latitude of 29.9792 degrees north. At first glance, that is simply a coordinate, a location on a map. But look closer. The speed of light in a vacuum is 299,792 kilometers per second. The numerical sequence is identical. Is this one of history's most incredible coincidences, or is it a signature, a deliberate marker left in the very fabric of the structure's placement? This alignment feels less like chance and more like a whisper from the architects, a hint that their knowledge extended far beyond quarrying and construction. The precision does not stop there. The Great Pyramid is oriented to the cardinal directions with an accuracy earlier researchers measured at just 3/60ths of a single degree of error. To achieve such alignment thousands of years ago speaks of a mastery of astronomy and surveying that challenges our conventional timeline. This combination of celestial alignment and coded numbers has led some researchers to a radical proposal. What if the Giza Plateau was not just a royal burial ground, but the center of an ancient world map? They suggest it may have served as a prime meridian, a fixed 0 point of longitude for a global coordinate system, long before the Royal Observatory at Greenwich claimed that role. Think of it as the anchor point on a vast, invisible grid. If this is true, then every other major ancient site could theoretically be plotted in relation to this Egyptian center. The Great Pyramid would be the reference point, the unmoving North Star in a terrestrial constellation. This transforms Giza from an isolated marvel into the probable heart of the network, the place from which all other geometric lines begin their journey across oceans and continents. From this central anchor, the lines of connection start to reveal themselves, pointing toward distant lands and other wonders waiting to be linked. From the heart of ancient Egypt, our gaze travels northwest across the Mediterranean and up into the misty green landscape of the British Isles. Here stands Stonehenge, its great sarsen stones a silent circle against the sky. For generations, we have understood it as a magnificent solar and lunar observatory, a calendar in stone. But its location holds a secret that stretches far beyond Salisbury Plain. The latitude of Stonehenge is 51 degrees, 10 minutes, and 44 seconds north. This is not just a random coordinate on a map. If you follow this precise line of latitude eastward, as if tracing a thread around the globe, you pass directly through an astonishing number of sacred and historically significant sites across Europe and into Asia. This path has been called a sacred circle of latitude, a highway of ancient veneration seemingly etched into the planet itself. The connection to Giza deepens the mystery in a profoundly mathematical way. The distance from the Great Pyramid to Stonehenge is not arbitrary. Researchers have calculated that it represents almost exactly 1/6 of the Earth's circumference. Think about that for a moment, 1 to 6. This simple ratio is a fundamental division of a circle, the same principle behind the 360 degrees of a compass, a system with roots in ancient Sumeria. This is not a vague approximation. It is a precise geometric relationship spanning over 2,000 miles. It suggests the builders of these sites were not just aware of each other's existence, but that they were using a shared, sophisticated understanding of the Earth's size. They were operating from a common blueprint, employing a consistent unit of measurement that allowed them to place their monuments in a deliberate, global pattern. This transforms our view of Stonehenge completely. It is no longer merely an isolated temple to the sun. Its towering trilithons become a kind of ancient survey beacon, a calibrated node in a planetary network. The stones do more than mark the solstice. They seem to whisper their position on a world-spanning grid to anyone who knows how to listen. The implication is staggering. It points to a lost epoch of exploration and communication, a time when knowledge of spherical geometry and global geography was not just possible, but was actively used to weave a web of sacred geography across the continents. What other points on this invisible web are waiting to be recognized, and what happens when we start connecting them with lines that run not just east and west, but in every direction across the map? This concept of a sacred latitude line finds a powerful echo in the ancient Greek world, at a place where myth and measurement seem to converge. High on the slopes of Mount Parnassus, the oracle of Delphi was revered as the Omphalos, the literal navel of the world. A strange, egg-shaped stone marked this sacred center. For centuries, we dismissed this as poetic mythology, a symbolic claim to cultural importance. But what if the priests and pilgrims were describing a tangible, geographical truth? Modern geodetic analysis reveals something startling. Delphi's position is not random. It sits at a precise intersection of energetic pathways often discussed in traditional studies, and more critically, it forms specific harmonic distances with other major sites. Its measured relationship to certain temples in Egypt, for instance, creates clean mathematical ratios, the kind that speak of intentional design rather than chance. This suggests the Greeks were not inventing a center, they might have been inheriting one. Their profound belief that Delphi was the Earth's midpoint could be a cultural memory, a faded echo of a much older understanding that this location was a central node in a vast pan-Mediterranean coordinate system. The oracle's placement was chosen with incredible care, aligning with solar and stellar events in a choreography that mirrors and complements rituals performed thousands of miles away. The piercing cries of the Pythia, the priestess channeling divine prophecy, may have risen from a site that was, in a very real scientific sense, a focal point. This intertwining of precise geography and powerful myth is the key. The term navel was likely not just a metaphor. In the language of a lost geodetic science, it could have been a technical term for a primary datum point, a central zero from which other distances were calculated. Delphi stands as a testament to how the sacred and the scientific were once inseparable, a single lens through which our ancestors viewed their place in a carefully measured cosmos. The journey from the Mediterranean to Southeast Asia stretches the imagination, yet the map insists we follow. In the dense jungles of Cambodia, the sprawling stone city of Angkor Wat rises, a monument so vast it feels like a world unto itself. For centuries, its towering spires and intricate bas-reliefs have been interpreted as a masterpiece of Hindu cosmology, a representation of Mount Meru, the center of the universe. But a new layer of meaning emerges when we look not just at the temple's art, but at its precise placement on the globe. Researchers have proposed a breathtaking celestial connection. The arrangement of Angkor's major temples appears to mirror the stars of the constellation Draco, but not as they are seen today. This terrestrial map matches the night sky from an astonishingly ancient epoch, around 10,500 years before the Common Era. It is as if the builders froze a moment in deep time and stamped it into the landscape. This alone is a concept that challenges our understanding of historical continuity, suggesting a preservation of knowledge across millennia. Yet the geodetic connection is even more precise, and it directly ties this Asian wonder back to the Egyptian Angkor. The longitudinal distance from the Great Pyramid of Giza to the central temple of Angkor Wat is exactly 72 degrees east. This number is not random. In the slow, grand clockwork of the heavens, it takes 72 years for the stars to appear to shift by a single degree along their path, a phenomenon known as the precession of the equinoxes. This 26,000-year cycle was understood by only the most advanced ancient astronomers. So here we have two of humanity's greatest architectural achievements separated by a distance that encodes a fundamental unit of cosmic time. The builders did not just create a static monument, they built a dynamic clock. Angkor Wat, in its relationship to Giza, becomes a marker in both space and time. The 72 degrees of separation tell us they knew the size of the Earth with enough accuracy to translate a celestial period into a terrestrial measurement. They were encoding the rhythm of the ages into the very longitude between their sacred sites. This transforms Angkor from our isolated jungle temple into a deliberate counterpoint to Giza, a second pillar in a global framework designed to measure not just land but the passage of epochs. The implication is profound. It speaks of a shared, ancient science that viewed the planet as a calibrated instrument for understanding the universe. If these 2 points are in such precise harmonic conversation, what other dialogues are written in the silent distances between the world's other ancient wonders? The silent plains of Peru hold a riddle written on a scale so vast it defies earthly comprehension. The Nazca lines are not monuments you walk around. They are a canvas you must ascend to the sky to truly see. Etched into the dark desert pavement are hundreds of geometric shapes and animal figures, some stretching over 600 feet long. For decades, the prevailing mystery was their purpose. Were they ritual pathways, astronomical calendars, or messages to the gods? But a more grounded, yet equally profound, possibility emerges when we view them through the lens of geodetic science. What if these immense glyphs were also a sophisticated survey grid, a terrestrial blueprint of staggering precision? Many of the most famous lines are not just pictures, they are arrow-straight pathways that run for miles across rugged, uneven terrain without deviating. Achieving such straightness over such distances, with no high vantage point for guidance, implies a mastery of geometry and sighting techniques that rivals modern engineering. These lines do not wander, they point. Researchers have documented how numerous lines align precisely with the solstice sunrise and sunset, anchoring the vast desert map to the solar year. Others seem to target distant mountain peaks or converge on sources of precious water, turning the entire plateau into a functional guide to the vital resources of a harsh landscape. This transforms the Nazca lines from mysterious art into potential infrastructure, a colossal, living coordinate system. Each straight line becomes a vector, a directional pointer etched permanently into the earth. The spider, the hummingbird, the monkey, these famous figures might be symbolic markers placed at key intersections within this giant grid. Some researchers take this idea further, proposing that this Nazcan grid was not an isolated system. They suggest these lines could have been regional survey points, part of a larger South American network connecting to the imperial capital of Cusco, high in the Andes, or to the mysterious ruins of Tiwanaku near Lake Titicaca. The plateau itself, then, becomes more than a canvas, it becomes a calibrated instrument. It functions as a map, a calendar, and a surveying manual all fused into one, its purpose woven into the very alignment of its markings with the sun, the mountains, and the flow of water. This perspective does not diminish their spiritual significance, it deepens it. It suggests the Nazca people saw no separation between the practical and the sacred, between measuring the earth and communicating with the cosmos. Their landscape-scale art was a way to harmonize their world with the larger order of things, creating a permanent testament to their understanding of place, direction, and time. Across the Pacific, in the highlands of ancient Mexico, a different kind of precision emerges from the earth. Teotihuacan, the city of the gods, is a testament to measured harmony. Its grand avenue, the Street of the Dead, runs arrow-straight for miles, flanked by colossal pyramids that seem to obey a silent, geometric command. But look closer at a map and something immediately stands out. The entire city grid is rotated 15.5 degrees east of true north. This is not a construction error, it is a deliberate signature. The builders turned their backs on the cardinal directions to face a different guide entirely, the setting point of the Pleiades star cluster. For cultures across Mesoamerica, this tight grouping of stars, often called the Seven Sisters, was a celestial clock marking agricultural cycles and deep mythological time. By aligning their entire urban plan to its descent, the Teotihuacanos anchored their city not just to the land, but to the rhythm of the cosmos itself. They built a terrestrial reflection of a celestial pattern, making the city a permanent observatory for a specific, recurring heavenly event. This astronomical alignment is profound, but the mathematical harmony within the city's stones is what truly echoes across continents. The Pyramid of the Sun, the massive heart of Teotihuacan, holds a secret in its dimensions. Researchers have calculated that its base perimeter is a mere 1% smaller than the base perimeter of the Great Pyramid of Giza. 1%, given the vast ocean separating these sites and the thousands of years that may lie between their construction, This similarity stretches coincidence to its breaking point. It points toward something more fundamental, a shared understanding of sacred proportion. The relationships between the pyramids and temples of Teotihuacan further this idea. The ratios of distances between the Pyramid of the Moon, the Pyramid of the Sun, and the Ciudadela complex have been shown to encode the mathematical constant pi, the ratio of a circle's circumference to its diameter. This is not a number one stumbles upon by accident while piling stones. It is a sophisticated geometric principle deliberately woven into the city's blueprint. So what does this mean? We are presented with two equally revolutionary possibilities. The first is a transoceanic connection, a thread of knowledge that somehow spanned the Atlantic, carrying architectural and geodetic principles from the old world to the new. The second is perhaps even more intriguing, the independent discovery of universal harmonic rules. This suggests that advanced ancient cultures, by deeply studying geometry and astronomy, independently tapped into the same fundamental proportions that govern space, form, and vibration. Teotihuacan may stand as powerful evidence that this lost science of harmony was not the property of a single civilization, but a latent truth of the universe, waiting to be rediscovered by anyone who learned to measure the world with both precision and reverence. The sheer isolation of Easter Island makes its potential connection to this global grid the most haunting of all. 2,000 miles from the nearest inhabited land, this tiny volcanic speck in the vast emptiness of the Pacific Ocean feels like the very definition of a place apart. Its mysterious stone giants, the Moai, stand with their backs to the sea, their inscrutable gazes fixed upon the interior of their own small world. It is the last place you would expect to find a coordinate in a planetary design. And yet, its position on the map whispers of intention. Easter Island sits at approximately 27 degrees south latitude and 109 degrees west of the proposed Giza meridian. These numbers are not random. 109 degrees is a highly resonant figure, representing almost exactly 3/10 of the Earth's full 360-degree circumference. This is a clean, mathematical fraction of the entire planet. For a culture to place itself at such a point, they would need a breathtaking understanding of global geography. They would need to know the size of the sphere they lived on, and they would need the navigational skill to find and settle this specific, minuscule point in a trackless ocean. This leads to the unavoidable, profound question: was this island chosen? The traditional narrative tells us the ancestors of the Rapa Nui people arrived by canoe, guided by the stars and the waves. But what if their legendary navigators were doing more than just finding land? What if they were following a star path to a predetermined location, a point calculated to hold a specific geometric relationship to other, far distant nodes in an ancient understanding of the world? The Moai themselves may hold a clue. Their inland-facing orientation has long puzzled visitors. If they were guardians or deities, why not face the sea, the source of both life and potential threat? Some researchers propose their placement creates precise solar alignments, turning the island into a calendar. Others see them as monumental navigational markers, their distinctive profiles serving as sighting points for voyagers approaching from specific directions. This transforms the Moai from isolated statues into active components of a system. They become fixed points of reference on a landscape that was itself a fixed point on a globe. The Polynesian voyagers who settled Rapa Nui possessed arguably the most sophisticated art of wayfinding ever developed, a living geodetic science. They read the stars, the swells, the flight of birds, and the composition of clouds to traverse thousands of miles of open ocean with pinpoint accuracy. Their mental maps were four-dimensional, charting not just space but time and current. In this context, Easter Island ceases to be a lonely mystery. It becomes a potential masterpiece of that science, the ultimate testament to a culture that didn't just cross the Pacific, but who may have understood their place within its geometric fabric. It stands as the most remote sentinel, a silent witness to the possibility that the ancient world's map was truly planetary in its scope, leaving no ocean, no matter how vast, uncharted by intention. A global map requires a shared language of measurement. Across the vast distances separating these ancient sites, we find a startling consistency in the very rulers they used to build. In the stone circles of Britain, the meticulous surveys of Professor Alexander Thom revealed a recurring standard he termed the megalithic yard, a unit of roughly 2.72 feet. This measure was not a rough approximation. It was used with remarkable precision across hundreds of sites, from the outer ring at Stonehenge to remote Scottish henges, suggesting it was the fundamental template for megalithic construction. Meanwhile, in the sands of Egypt, the builders of the pyramids employed the royal cubit, a unit of about 1.72 feet, which is found encoded in the dimensions of every chamber, passage, and casing stone of the Great Pyramid. At first glance, these appear to be two separate standards from two different worlds, but mathematics tells a different, more unifying story. The ratio between the megalithic yard and the royal cubit is not a random number. It relates directly to fundamental constants like pi and the golden ratio, those same harmonic proportions we see echoed in temple layouts across the globe. This is not a coincidence, it is a clue. It suggests these were not independent inventions, but perhaps two branches of the same ancient metrological tree, two variations on a core unit of measure derived from a common source of knowledge. The implications of this are profound. For cultures separated by oceans and millennia to use variations of the same fundamental measure implies a shared scientific heritage. It points to the possibility of a prehistoric science of the Earth, a unified system of geometry and geography that fragmented over time into the regional practices we now study in isolation. But where could such a universal standard have come from? The answer may be written in the dimensions of the planet itself. Researchers have long proposed that these ancient units were not arbitrary lengths based on a king's forearm or a random stick. Instead, they may have been derived directly from geodetic survey, from measuring the Earth. For instance, 1/10,000,000th of the Earth's polar radius, or a specific fraction of its circumference, could yield a unit very close to the megalithic yard or a multiple of the royal cubit. Think about that for a moment. It means the ultimate reference, the master ruler for this entire ancient enterprise, was not kept in a temple or a palace. It was the planet under their feet. By observing the stars and measuring the shadows cast over vast distances, these early scientists could have calculated the Earth's size with surprising accuracy. They then would have created a human scale unit that was a precise fraction of that global whole, turning every local measurement into a reflection of a planetary constant. This transforms our understanding of their monuments. When a builder laid out a stone circle using the megalithic yard, he was not just spacing stones, he was imprinting a tiny piece of the Earth's circumference onto the landscape. When an Egyptian architect specified dimensions in royal cubits, he was building in units that resonated with the very sphere of the world. This shared metrology becomes the silent, physical proof of the network, the hard evidence that these cultures were not just vaguely aligned in thought, but were literally speaking the same mathematical language, using the same calibrated tools to inscribe their shared vision onto the globe. If the units themselves were born from the Earth, then what other planetary secrets might be locked within the simple act of measuring a wall or pacing out a foundation? The sun's journey was the first and most reliable clock humanity ever knew. From the moment our ancestors first watched the light shift along the horizon, they understood its path held meaning, marking the seasons of planting and harvest, of warmth and cold. This universal observation led to a universal architectural practice. Structures as diverse as the Great Tomb of Newgrange in Ireland, with its narrow light box perfectly designed to flood the inner chamber with the winter solstice sunrise, and the mountaintop citadel of Machu Picchu in Peru, where the Intihuatana stone pillar casts no shadow at the equinox, were built as instruments to capture these celestial moments. This was far more than symbolic ritual. It was the bedrock of practical astronomy and community survival. By marking the sun's extreme northern and southern risings on the solstices, ancient builders created a precise, local solar calendar etched in stone, a way to anchor their lives to the reliable rhythm of the cosmos. But what happens when we step back from these individual sites and view them all together on a global map? A deeper layer of intention reveals itself. It begins with a simple yet profound observation. A monument aligned to capture the sunrise on the summer solstice is facing a very specific direction, a line drawn from its location to a precise point on the distant horizon where the sun peaks over the edge of the world on that longest day. Now extend that line. Follow it not just to the local horizon, but across continents and oceans, tracing its path along the curve of the Earth. Researchers have found that these solstice alignment lines, when plotted globally, do not simply vanish into empty space. Astonishingly often, they connect directly to another ancient, sacred site thousands of miles away. It is as if one temple's doorway for the sun points like a celestial arrow toward another temple's doorway. This creates something beautiful and immense, a web of solar pathways woven across the entire planet. Imagine a network where the winter solstice sunrise line from a temple in India might pass through a sacred mountain in Tibet before touching a stone circle in Scotland. Or where the sunset alignment on the summer solstice from a pyramid in Mexico points directly toward a ceremonial center in the American Southwest. These are not random intersections. They suggest a coordinated, or perhaps an inherited, effort to mirror the sun's annual journey in a planet-wide architectural symphony. Each site becomes both an observer and a beacon, a point where light is captured and a direction is declared. This transforms our understanding of these alignments. They were not just local calendars, they were also long-distance connections, threads of light and geometry stitching the ancient world into a unified whole. The builders, by anchoring their sacred spaces to the same celestial events, were unconsciously or deliberately placing them on a shared grid defined by the sun itself. It means that when the dawn broke over Newgrange, it was not just illuminating an Irish tomb, it was activating a node in a network that spanned the globe, a silent moment in a ceremony whose full scale we are only now beginning to perceive. The heavens hold a secret rhythm far slower than any season. Beyond the annual dance of the sun lies a grand 26,000-year cycle known as the precession of the equinoxes, a slow wobble in the Earth's axis that gradually shifts our view of the stars. It is a timescale so vast it defies human lifespans, a cosmic clock whose single tick spans hundreds of generations. Yet, woven into the very placement of ancient monuments, we find what appears to be a conscious recording of this immense celestial pulse. The number 72, the precise longitudinal separation between Giza and Angkor, is not just a distance, it is a key to this clock. In the mathematics of precession, the stars appear to shift 1 degree along the ecliptic every 72 years. This means the builders did not just measure space between their sites, they encoded a fundamental unit of cosmic time. That distance is a permanent inscription of a celestial truth, a deliberate equation where space literally equals time. This encoding becomes even more profound when we examine the monuments themselves. The dimensions of the Great Pyramid are a library of mathematical constants. Its proportions incorporate pi, the golden ratio, and relationships that mirror the Earth's own dimensions. Scholars have long noted that if you take the pyramid's height and multiply it by a specific precessional number, you arrive at a figure remarkably close to the polar radius of our planet. This is not random numerology, it is architecture as astrophysics. The pyramid seems designed as a scale model of the northern hemisphere, its stone geometry capturing both the shape of the Earth and the timing of its slow axial wobble. It becomes a frozen snapshot of planetary motion, a clock built for an age. This principle extends across the global network. When we map the longitudes of major ancient sites, a pattern emerges in the numbers. We find clusters at separations that are clean multiples of 72, 54, and 36 degrees. These are not random placements, they are deliberate fractions of the Earth's 360-degree circle, and by extension, fractions of the 26,000-year Great Year of Precession. A site placed 72 degrees from a prime meridian like Giza is marking 1/5 of the circle, a direct correlation to a 5,000-year segment of the cosmic cycle. Another at 108 degrees, or 3/10 of the circle, marks another significant epoch. The builders, it seems, were using the planet itself as the dial of a clock, with their monuments as the fixed numbers. Each sacred location was a marker on a timeline so vast it encompassed human history itself. This transforms our entire understanding of the coordinate system. It is no longer a static map for navigation or land survey. It becomes a dynamic timeline, a calendar built on a planetary scale. The monuments were not just placed to be seen from the ground or the sky in their own era. They were positioned to be read across the millennia. They are fixed stars in a terrestrial constellation, ticking in harmony with the slowest rhythm we know. The implication is humbling. It suggests these ancient cultures saw their place not just in the landscape, but in deep time. They built to communicate across the ages, leaving a message in latitude, longitude, and stone that said, "We were here, we measured the world, and we understood its place in the turning of the great wheel." The pyramids of Giza hold a secret written in the stars. One of the most compelling theories to emerge from this field of ancient alignment is the Orion correlation, proposed by researchers Robert Bovell and Adrian Gilbert. They observed that the three great pyramids on the Giza plateau are not arranged in a perfect line or a simple triangle. Instead, their layout mirrors the three stars that form Orion's belt, but with one intriguing twist. The pyramid pattern matches the precise asterism as it would have appeared in the night sky, not during the traditional dating of the pyramids, but in a far more ancient epoch, around 10,500 years before the Common Era. This correlation suggests the builders were encoding a specific moment in deep time, freezing a celestial snapshot into the limestone of the desert. The metaphor extends across the entire landscape. In this cosmic model, the winding course of the Nile River is seen as a terrestrial reflection of the Milky Way, the great celestial river of the heavens. If this is true, then other temples and monuments across Egypt might correspond to other bright stars in the constellation, creating a vast, country-sized map of the heavens laid upon the earth. The theory, while debated, is powerful because it perfectly exemplifies the ancient worldview we have been tracing. It was not enough to simply observe the stars. The desire was to recreate them, to anchor the celestial order permanently onto the terrestrial plane. This turns the land of Egypt into a sacred mirror, where every stone structure becomes a point of contact between the human and the divine. This idea does not have to be confined to the Nile Valley. If one culture sought to build a reflection of the heavens, could others have done the same? It raises a fascinating possibility that other clusters of ancient monuments around the world might also be terrestrial maps of specific constellations. A group of temples in Cambodia could map Draco. A series of mounds in North America might trace Cygnus, or a line of sacred mountains in South America could outline the Southern Cross. This transforms our entire perspective. We begin to see the planet not just as a canvas for isolated wonders, but as a single, immense planetarium constructed over millennia by cultures who shared a unified vision. They were not just building for their own communities, they were collaborating across time and space to build a model of the cosmos itself, with each sacred site serving as a fixed star in an earth-bound firmament. The grandeur of this concept is almost beyond comprehension, suggesting a collective project of such scale and patience that it redefines our understanding of ancient purpose. But a map is only useful if it guides a journey. Before compasses and satellites, how did ancient travelers navigate trackless oceans and uncharted continents? The answer may be written in the very stones we have been mapping. These monuments were not just symbolic markers or passive observatories. They were active waypoints in a physical internet of the ancient world. By situating their temples, mounds, and stone circles along great circle routes, the shortest possible paths between 2 points on a sphere, these cultures created a navigable network that spanned the globe. Think of a great circle route like the string you would tie tightly between 2 points on a basketball. The string always follows the curve for the most direct journey. This is how modern aircraft fly between continents, and it appears to be exactly how ancient voyagers plotted their courses. A sailor setting out from a known port, marked by a prominent pyramid or a towering stone circle, could sail toward the next known site on the Great Circle path, using the sun by day and the stars by night to hold his course. The monuments themselves acted as both destination and confirmation, colossal lighthouses confirming you were on the right path across the featureless sea or the endless plain. Take one of the most astonishing examples, the Great Circle route from the Giza Plateau to the remote isolation of Easter Island does not traverse empty ocean. Analysis shows this shortest path passes directly through, or remarkably close to, several other potent ancient locations, including the mysterious ruins of Mohenjo-Daro in the Indus Valley and the ancient ceremonial complex of Nan Madol, built upon a coral reef in the Pacific. This is not a random line on a map, it is a highway of antiquity with built-in rest stops and landmarks. This transforms our understanding of the system's purpose from a purely ceremonial or astronomical one to a profoundly practical one. It suggests this global coordinate system was functional infrastructure. It aided in exploration, guiding bold navigators to new lands. It facilitated trade, allowing for the reliable exchange of goods, ideas, and technologies across continents. Most importantly, it enabled cultural exchange, weaving a tapestry of shared myth, measurement, and knowledge that connected humanity long before written history claimed such connections were possible. The monuments were the nodes and the Great Circle routes were the cables. A traveler did not need a parchment chart. He needed to know the stories, the star paths, and the sacred geographies that pointed from one known point to the next. This network implies a level of organized long-distance interaction that rewrites the narrative of isolated ancient civilizations. It paints a picture of a world that was interconnected, where a pilgrim, a trader, or an explorer could undertake a monumental journey with a known sequence of destinations, each one a beacon of civilization in the wilderness, guiding them step by step across the curve of the earth. The stones themselves seem to whisper of a different kind of current. Beyond the precise mathematics of star alignments and global distances, there exists a persistent, almost intuitive thread in many ancient traditions, a belief in invisible pathways of power crisscrossing the Earth's skin. Modern researchers often call these ley lines, a term that can evoke everything from mystical energy grids to discredited archaeology. But what if, in dismissing the more fantastical claims, we have overlooked a genuine, observable phenomenon that the ancients were simply better at perceiving? The investigation leads us away from the stars and down, deep into the ground beneath our feet. It is a compelling fact that so many of these precisely placed monuments sit directly atop unique geological features. Underground water streams, powerful magnetic anomalies, and the junctions of tectonic fault lines are not uncommon beneath ancient temples and stone circles. Researcher Paul Devereux has spent decades documenting this correlation, proposing that our ancestors were exquisitely sensitive to these subtle telluric, or earth energies. They may have chosen their sacred sites not just for the view of the heavens, but for the palpable feel of the place, for a vibrational quality we have largely lost the ability to sense. Think of it this way: if you were to build a receiver for celestial information, where would you place it? You would likely seek a location with minimal interference, clear sight lines, and perhaps a stable, resonant foundation. Now consider the Earth not as a dead rock, but as a living, pulsing body with its own rhythms, its own flows of water, mineral, and magnetic force. An underground aquifer creates a subtle electrical charge as water moves through rock. A fault line can release measurable gases and electromagnetic pulses. A concentration of certain minerals can distort the local magnetic field. To a culture deeply attuned to their environment, these places would feel different. They would hum with a tangible presence. The act of building a massive stone structure, often from crystalline rock like granite or quartz, could have been a way to amplify, focus, or simply mark this terrestrial vitality. The great stone circles of Britain, for instance, are frequently found at sites with pronounced magnetic variations. The pyramids of Giza sit atop a substantial limestone aquifer. The temples of Angkor are intertwined with a vast, engineered water management system that seems to channel the land's essence as much as its rainfall. This suggests that geodetic science was not cold calculation alone. It was a holistic practice. Astronomy gave them the map in the sky, geometry gave them the means to plot it on the land, and a profound sensitivity to the Earth's own energy signatures told them exactly where to place the pin. They sought the confluence, the perfect node where the celestial and the terrestrial converged. Whether we interpret these Earth energies in modern terms of geophysics, subtle electromagnetism, or something not yet defined by our instruments, the consistency is arresting. It paints a picture of ancient builders who saw no separation between spirit and science, between the energy of life and the physics of place. Their global coordinate system, then, may have been more than a map or a clock. It might have been a schematic for a planetary circuit, a deliberate network connecting points of heightened terrestrial power, wired together by lines of sight and intention, creating a kind of resonant engine tuned to both the Earth below and the cosmos above. The deep past holds a secret locked inside a lump of corroded bronze. In 1901, divers exploring a Roman-era shipwreck off the coast of the Greek island of Antikythera brought up a strange, fragmented object. For decades, it sat in a museum drawer, a curiosity assumed to be a decorative piece or a navigational tool. Then, painstaking analysis and modern imaging techniques revealed its true nature. The Antikythera Mechanism, dating to around 100 years before the Common Era, is the world's oldest known analog computer. Its intricate system of at least 30 bronze gears, housed in a wooden case, was a portable cosmos in a box. By turning a hand crank, an ancient scholar could model the motions of the sun, moon, and 5 known planets, predict solar and lunar eclipses, and even track the cycles of athletic games like the Olympics. This was not a simple calendar. It was a dynamic simulation of the heavens, a mechanical representation of celestial harmony. Its very existence is a thunderclap in our understanding of ancient technological capability. It proves beyond any doubt that certain cultures of antiquity possessed a mathematical and engineering sophistication we had scarcely dared to attribute to them. The knowledge required to build such a device is staggering. The designers needed a precise understanding of the Saros and Metonic cycles, complex patterns governing eclipses and lunar phases. They had to translate these long-term astronomical relationships into physical gear ratios, some with teeth numbering in the hundreds, machined with astonishing accuracy. This implies a deep, working knowledge of spherical geometry and trigonometry, the very mathematical language needed to navigate the curved surface of a sphere and plot positions upon it. The mechanism is a microcosm, a tiny, intricate model of the cosmic order. And if the ancient Greeks or the even earlier civilization from which they may have inherited this knowledge could miniaturize the cosmos into a handheld device, is it truly so far-fetched to believe they could have done the opposite? Could they have projected that same understanding outward, using the principles embedded in those bronze gears to conduct surveys on a planetary scale? The Antikythera Mechanism serves as a crucial, tangible clue. It bridges the gap between theoretical knowledge and practical application. It tells us that the intellectual tools necessary to conceive of a global coordinate system, the ability to calculate angles, model spherical relationships, and predict celestial events years in advance were not just philosophical abstractions. They were concrete, applied sciences capable of producing working technology. This one artifact shatters the illusion of primitive antiquity. It forces us to reconsider what else might have been possible. If they could build a machine to predict the dance of the heavens, then plotting that same dance onto the Earth's surface becomes a logical, even inevitable, next step. The gears of the Antikythera Mechanism, frozen in time, still turn in our minds, urging us to see the ancient world not as a collection of isolated mysteries, but as a continuum of advanced knowledge, much of which now lies silent beneath the waves of history. The Great Sphinx stares eternally toward the rising sun. Its gaze is not a random orientation, but a precise and deliberate lock on a single, fleeting moment in the celestial year. This colossal guardian of the Giza plateau is perfectly aligned to face the exact point on the horizon where the sun rises on the spring equinox, that day of perfect balance when light and darkness hold equal measure across the world. For the ancient Egyptians, this was far more than a seasonal marker. The equinox represented a moment of cosmic harmony, a fleeting instant where the sun's path, the ecliptic, intersects with the celestial equator, the great imaginary circle in the sky directly above the Earth's middle. The Sphinx, in its monumental stillness, captures that intersection and holds it fast. It transforms an astronomical event into a permanent architectural fact, a moment of universal balance frozen in limestone for eternity. But to see this as an isolated feature is to miss the scale of the vision. The Sphinx's equinoxial alignment is not a solo performance. It is a single note in a planetary chord. Researchers looking at a global map have noticed something remarkable. Other ancient monuments, from the great temple of Angkor Wat to certain megalithic sites in the Americas, also demonstrate precise alignments to the equinox sunrise or sunset. When you plot these sites, they do not appear randomly scattered. Instead, they seem to cluster along a specific band encircling the Earth, a terrestrial echo of the celestial equator itself. This proposed band has been called an equinoxial belt, a global line of sites all honoring the same fundamental principle of balance. Think of it as a ring of sacred places, all built to acknowledge the same moment of cosmic equilibrium, each one a local witness to a global truth. The Sphinx, then, becomes more than a guardian of pyramids. It transforms into a primary sentinel on this planetary band, a fixed marker for a celestial coordinate that was recognized and revered across cultures. Its purpose expands from the mystical to the geodetic. By marking the equinox with such unwavering precision, it establishes a fixed directional line due east that can be used as a reference for other measurements. It anchors the entire Giza complex, and by extension any site connected to it, to a fundamental axis of the cosmos. This alignment to balance may have been the ultimate organizing principle, a way to harmonize human construction with the most stable, symmetrical line in the heavens. The Sphinx, therefore, is not merely watching over the sands of Egypt. It is gazing down a line of longitude that stretches around the world, connected to other sentinels in distant lands, all built to celebrate the same eternal return of light and dark in perfect harmony. The vast Eurasian steppe whispers a different kind of alignment, written not in towering pyramids but in standing stones. Scattered across the Mongolian landscape are ancient sentinels known as deer stones, megaliths carved with intricate, flowing bands and stylized images of leaping stags. These are not random monuments. Dating back over 3,000 years to the Bronze Age, these stones are frequently found standing in precise rows or circles, their carved faces and the lines etched upon them pointing deliberately toward distant, sacred features of the land. They align with the peaks of holy mountains, the mouths of river valleys, or the path of the sun on a solstice dawn. While they have not received the same intense study as Stonehenge or Giza, their silent testimony is profound. They tell us that the deep impulse to survey the landscape and encode cosmic order into stone was a universal human language, spoken fluently on the open plains of Asia, just as it was in the deserts of Egypt or the jungles of Cambodia. Each cluster of deer stones appears to form a local grid, a microcosmic coordinate system that oriented nomadic communities within the immense, seemingly endless horizon. They provided fixed points in a mobile world, anchoring ceremony and memory to specific places where the earth met the sky in a meaningful way. But what if these local grids were not isolated? When we pull back the map, a tantalizing possibility emerges. The alignments established by these Mongolian stones may form connecting threads to other great Asian sites. Could lines radiating from these step markers point toward the enigmatic pyramid mounds of ancient China, like those at Xi'an? Might they intersect with the sacred geometries of Hindu temples in India, or even link to the great stone complexes of Siberia? The deer stones suggest a continental scale pattern of sacred geography, a network of knowledge that flowed along the same trade routes that carried goods and ideas across the Silk Road. They remind us that this science of alignment was not the exclusive property of so-called advanced civilizations with written records and cities of stone. It was a shared understanding that emerged wherever people looked up at the stars and sought to find their reflection in the world below. The nomadic herder who raised a deer stone to mark a solstice sunrise was participating in the same fundamental project as the priest astronomer charting the heavens from a Mayan temple or the master builder laying out the foundation of an Egyptian tomb. This universal impulse bridges cultures and continents, revealing a collective human endeavor to weave our stories into the very fabric of the planet. Deep within the Amazon, a hidden geometry emerges from the soil. For centuries, the dense rainforest canopy guarded a secret, preserving the myth of an untouched wilderness. Then, laser technology peered through the leaves. Known as LiDAR, it revealed what the jungle had concealed: vast earthworks of staggering precision etched into the ground below. Across hundreds of sites in western Brazil, geometric forms appear: perfect circles, clean squares, and straight lines that run for miles. These are not natural formations. They are geoglyphs, monumental earth sculptures created over 2,000 years ago by cultures we are only now beginning to name. Their discovery is a revolution in our understanding of the ancient Americas. It shatters the old narrative of a pristine, empty jungle and reveals instead a landscape meticulously managed and intelligently designed. The builders moved immense amounts of earth to create these enclosures, demonstrating a sophisticated command of engineering and a highly organized society. But the true mystery lies not just in their existence, but in their form and orientation. These Amazonian earthworks are not haphazard. They are aligned with a deliberate, knowing hand. Many of the large circular and square compounds are oriented to the cardinal directions, their sides running true north-south and east-west with an accuracy that speaks of careful astronomical observation. Some of the long, linear earthworks appear to point toward the solstice sunrise or sunset, anchoring these jungle clearings to the same cosmic cycles revered by cultures on other continents. This precise alignment transforms them from mere ceremonial spaces into potential components of a vast regional coordinate system. Imagine a network of these geometric clearings, connected by sight lines through the forest or by the intentional orientation of their earthworks, creating a map across the Amazon basin. Each site could have been a node, a known point used for navigation, seasonal gathering, or marking territorial and sacred boundaries. The knowledge required to execute this is profound. To lay out a perfect square or a mile-long straight line in dense, uneven jungle terrain requires more than manpower. It demands advanced surveying techniques and a shared standard of measurement. This places the ancient Amazonians squarely within the global conversation. They were not isolated tribes, but landscape architects on a grand scale, participating in the same fundamental human project as the pyramid builders and the stone circle architects. They too were reading the sky and translating its order onto the earth, using soil and sweat instead of stone. Their geoglyphs introduce a powerful new player into the alignment mystery, proving that this science of sacred geography was not confined to deserts or open plains. It flourished even under the green cathedral of the rainforest, a testament to the universal human desire to find pattern, meaning, and connection in the world we inhabit. These recurring numbers are the silent signature of a universal language. In the precise angles of the Great Pyramid and the elegant columns of the Parthenon, we find the same mathematical constants that appear throughout the natural world. This is not a coincidence of style, it is a profound declaration of understanding. The number pi, approximately 3.1416, is the fixed ratio of a circle's circumference to its diameter. It appears in the swirling arms of distant galaxies, in the ripples on a pond, and remarkably, in the very stones of Giza. The Great Pyramid's base perimeter, when compared to its original height, yields a ratio extremely close to 2 times pi. This means the builders essentially squared the circle, a geometric feat of deep symbolic meaning, embedding a fundamental truth of spherical geometry into a 4-sided structure. Across the Mediterranean, the architects of the Parthenon in Athens employed a different but equally universal constant, the golden ratio, often denoted by the Greek letter phi, approximately 1.618. This ratio, where a line is divided so the whole is to the larger part as the larger part is to the smaller, creates a proportion celebrated for its inherent beauty and balance. It is visible in the spiral of a nautilus shell, the branching of trees, and the facial proportions considered most harmonious. The Parthenon's facade is a masterpiece of phi, its width to height, the spacing of its columns, all carefully calibrated to this natural proportion. Now consider the staggering implication. These are not just pretty numbers used for local art. Pi and phi are transcendental constants. They exist independently of human invention, woven into the fabric of space, form, and growth. By embedding these universal constants into monuments that are also precisely placed on the Earth's surface according to a global coordinate system, the ancient designers were making a philosophical statement of breathtaking scope. They were demonstrating a unified theory of reality. Their message, written in limestone and marble, seems to be this: the same mathematics that describes the orbits of planets, the growth of a sunflower, and the curve of a seashell also describes the ideal proportions of the Earth itself and humanity's sacred places upon it. The pyramid is not just a tomb, and the temple is not just a house for a god. They are physical equations, 3-dimensional proofs that the cosmos is ordered, knowable, and beautifully consistent. In building this way, they were not merely constructing shelters, they were aligning human creation with the deepest principles of existence, showing that our place in the cosmos is not random, but part of a grand, intelligible, and mathematically elegant design. The ground beneath our feet is not as permanent as it seems. For all the precision we have traced across the globe, a profound complication emerges from the very axis of the planet itself. What if the Earth's skin has slipped? This is the core of the pole shift hypothesis, a concept explored by researchers like Charles Hapgood. It suggests that the entire outer crust of our planet can, over great spans of time, shift as a single unit over the molten layers below, a process called true polar wander. This is not a change in the magnetic poles, which flip regularly, but a physical reorientation of the geographic poles themselves. Imagine spinning an orange, then gently sliding its peel around the stationary fruit inside. The continents move together, and the north and south poles relocate to new points on the surface. If such an event occurred in humanity's deep past, it would rewrite every map, celestial and terrestrial, that our ancestors ever made. A temple built to face the North Star of its era would, after a shift, no longer point north at all. Its sacred alignments would now target empty space, a silent monument to a lost sky. This radical idea offers a potential key to one of archaeology's most persistent puzzles. Take Göbekli Tepe in Turkey, a site that rewrites history with its staggering age of over 11,000 years. Some of its carved pillars and enclosures appear aligned not to the stars of its conventional construction date, but to the night sky as it would have appeared several thousand years earlier. Under the pole shift model, this makes a startling kind of sense. The builders of Göbekli Tepe may have perfectly aligned their stone circles to their contemporary celestial pole. Then, a subsequent crustal shift moved the entire region, and with it the site's orientation, so that it now inadvertently points to an older stellar configuration. The monument itself did not move, but the world rotated beneath it. This transforms our understanding of the global coordinate system from a static grid into a dynamic, layered record. It becomes a palimpsest, an ancient parchment where one map has been scraped away and another drawn over it, with faint traces of the original still visible beneath. Monuments that seem slightly off in their alignments today might not be errors of ancient surveyors, but perfect calibrations to a previous version of the Earth. Their slight misalignments are not mistakes, they are fossils of a former global geography. This adds a breathtaking layer of temporal depth to the entire geodetic code. We are not just looking at a single snapshot of ancient knowledge, but potentially at multiple snapshots taken at different points in a planetary drama. Each site could hold a memory of where true north once stood, a stubborn stone witness to a world that literally turned upside down. The coordinate system, then, is not merely a map of space, but a recording of planetary time, a testament written in aligned stone to the profound instability and majestic change of the very globe we call home. These recurring myths are not just isolated bedtime stories. When you stand before the silent stones of Giza or walk the long avenue of Teotihuacan, you are not merely looking at architecture, you are walking through a shared dream of humanity's past. Around the world, the foundational stories of cultures separated by vast oceans tell eerily similar tales. The ancient Egyptians spoke of Zep Tepi, the first time, an epoch when the gods walked the earth and established the perfect order of creation. The Hindu tradition describes the Satya Yuga, a golden age of truth and righteousness, where humanity lived in harmony with divine law. The Greeks, through Plato, passed down the cautionary legend of Atlantis, a mighty island kingdom of unparalleled advancement that sank beneath the waves in a single day and night. Across the Americas, among the Maya, the Hopi, and the peoples of the Andes, stories persist of previous worlds destroyed by flood or fire, each giving way to the next. What binds these narratives together is a core memory of a lost epoch, a time when beings of great knowledge established the blueprints for civilization, a time before a great cataclysm reset the world. It is a hauntingly consistent global refrain, a chorus of memory sung in 1,000 different tongues. Now, overlay this map of myth onto the map of geodetic alignments we have been tracing. The correlation is striking. The regions richest with these profound myths of a golden age and a great flood are often the very same regions where we find the most precise and interconnected monumental alignments. The Nile Valley, the Indus Valley, Mesopotamia, the highlands of Mexico and Peru, the islands of the Pacific, all are landscapes dense with both legend and coordinated stone. This is not likely a coincidence. It suggests these stories are not pure fantasy, but rather cultural memories distorted by time and retelling of a real historical reality. The myths describe the software, the living knowledge and societal wisdom of that precursor culture. They speak of a people who understood the stars, the shape of the earth, and the principles of harmony. The monuments, then, are the surviving hardware. They are the physical, enduring evidence of that knowledge, the tangible skeleton of a world-spanning civilization that encoded its understanding directly into the planet's geography. When a priest in ancient Egypt recited the lore of Zep-Tepi, he was recalling a time when the Sphinx's gaze was first locked to the equinox. When a Hindu scholar contemplated the Satya Yuga, he was imagining an age when the cosmic principles reflected in temple geometry were actively practiced. These global stories form the narrative wrapper for the geodetic code, giving purpose and context to the silent mathematics of stone and earth. They tell us that this coordinate system was not a cold, technical project, but the physical legacy of a lost world's consciousness, a civilization so advanced in its unity with nature that its greatest achievement was to weave itself and its memory into the very fabric of the earth itself. The silent patterns across the planet now meet the piercing gaze of the digital eye. Our modern era has gifted us a suite of tools that transform speculation into measurable data, allowing us to test these grand theories of a global network with a rigor the original builders might have admired. Satellite archaeology, using cameras in space to peer through forest canopies and detect subtle earthworks invisible from the ground, has unveiled lost cities and ceremonial centers, adding countless new points to our ancient map. Meanwhile, Geographic Information Systems, or GIS, provide the digital canvas. This powerful software allows researchers to plot the precise coordinates of thousands of ancient sites onto a virtual globe, then run complex analyses, drawing lines, calculating distances, and searching for statistical patterns that defy simple chance. It is a marriage of space-age technology and age-old mystery, a way to see the forest for the trees on a planetary scale. Large-scale projects have now mapped these connections across continents, and what emerges is not random noise. While a skeptic might rightly argue that with enough points scattered across a sphere, you can always draw some interesting lines, the data reveals consistencies that are harder to dismiss. Certain angles, like multiples of 7.5 or 15 degrees, appear with surprising frequency in the alignments between major sites. Specific distances, measured as clean fractions of the Earth's circumference, 1/10, 1/6, 1/4, recur with a regularity that feels intentional. These are not the vague approximations of primitive guesswork, they are the precise signatures of a mathematical mind. The role of modern technology, therefore, is not to debunk the mystery, but to illuminate it. It provides the hard, quantifiable data that makes the subtle patterns starkly visible. The lines on the map grow from intriguing suggestions into compelling evidence, forcing a serious and respectful re-evaluation of what ancient cultures were truly capable of achieving. We are no longer just connecting dots based on intuition. We are calculating probabilities and measuring geometries with tools that confirm the ancients operated with a knowledge we are only now relearning how to see. This digital confirmation does not simplify the story, it deepens it, transforming a collection of fascinating coincidences into a coherent, planet-wide puzzle waiting to be solved. But a compelling story must also face its critics. The most common and powerful rebuttal to this global alignment theory is one of simple chance. Mainstream archaeology and skeptical scholars offer a grounded counter-narrative, urging us to consider the immense power of coincidence, the vastness of the Earth, and the innate human drive to find order in chaos. They point to a psychological phenomenon known as apophenia, our brain's tendency to perceive meaningful connections between unrelated things. Given thousands of ancient sites scattered across the globe, they argue, it is statistically inevitable that some will align by pure accident. Draw enough lines on a map, and you will eventually connect a pyramid to a temple to a stone circle, creating a pattern that feels intentional but is ultimately an illusion of selective data. This perspective is not dismissive, it is a necessary call for scientific rigor. It reminds us that extraordinary claims demand extraordinary evidence, and that the burden of proof lies with those proposing a coordinated, planet-wide plan. From this viewpoint, the similarities we see are not evidence of a lost global civilization, but of shared human ingenuity facing similar universal challenges. Different cultures observing the same sun, moon, and stars would naturally develop similar architectural solutions. Aligning a monument to a solstice sunrise is a practical, repeatable discovery, not proof of transoceanic communication. The appearance of mathematical constants like pi or the golden ratio in different structures is also explained not by shared secret knowledge, but by the inherent properties of geometry itself. If you build using ropes and stakes to create circles and right angles, these universal constants will emerge organically in your proportions. They are built into the fabric of mathematics, waiting to be rediscovered by any culture that explores form and space with enough depth. The traditional model of cultural diffusion, where ideas spread slowly through contact between neighboring regions, is seen as sufficient to explain the spread of technologies and architectural styles. There is no need, the skeptic argues, to invoke a mysterious, advanced precursor culture when the gradual, documented march of human innovation fits the evidence. This challenge is vital. It forces the alignment hypothesis to be more than a collection of intriguing coincidences. It demands contextual evidence, like artifacts or writings found at these sites that explicitly reference long-distance surveying or a shared geodetic science. It asks for a clear, testable mechanism of how such precise global coordination could have been achieved with the technology of the time. Engaging with this skepticism does not weaken the mystery, it deepens the conversation. It transforms the discussion from fringe speculation into a legitimate historical puzzle, where both sides must sharpen their arguments against the whetstone of evidence. The true answer may lie not at one extreme or the other, but in a nuanced middle ground we have yet to fully map. This profound possibility carries a weight far greater than academic curiosity. If the stones of the world truly sing in geometric harmony, then the melody belongs to everyone. The knowledge embedded in this planetary network is not the property of any single modern nation, corporation, or academic institution. It is a shared heritage of humanity, a collective inheritance etched into the bedrock of our common home. This realization immediately raises urgent and delicate questions of ethics and respect. How do we, as a global community, approach the study of sites that are not merely archaeological curiosities, but living, sacred spaces for indigenous peoples? A temple mound in North America, a ceremonial platform in the Pacific, a stone circle revered by a local community. These are not open-air museums. They are churches, libraries, and ancestral homes. The pursuit of understanding this geodetic code must be guided by humility and collaboration, not extraction. It cannot be a one-way street where outside experts arrive, take measurements and artifacts, and leave with interpretations that silence the voices of those whose ancestors built these places. True decoding requires a dialogue. It means sitting with elders, listening to oral histories that have been passed down for generations, and recognizing that traditional knowledge often holds the keys that pure data cannot provide. A story about a star path, a song about a mountain's alignment, a ritual performed at a specific solar event. These are not myths to be dismissed, but potential user manuals for the landscape written in a living language. The interpretation of this global mystery must be a shared endeavor. We must vigilantly avoid the trap of old colonialist narratives that seek a single, superior lost race, Atlanteans, ancient astronauts, or otherwise, to whom all genius is attributed. That framework diminishes the breathtaking, diverse ingenuity of ancient peoples worldwide. It steals credit from the Maya astronomer, the Polynesian navigator, the Egyptian surveyor, and the Andean engineer. This story is not about one forgotten master culture, but about many cultures, potentially across many epochs, participating in a shared scientific and spiritual understanding of the cosmos. Their collective achievement reveals a chapter of our human story that emphasizes interconnection over isolation, astronomical wisdom over ignorance, and a profound, sacred relationship with the planet over domination. To recover this chapter is not to claim a secret for one group, but to reclaim a vision of unity for all. It reminds us that long before borders were drawn, humanity was capable of projects of sublime cooperation, using the Earth itself as a canvas to express our deepest yearning to belong to something vast, ordered, and beautiful. The ultimate value of solving this mystery may not be in proving who knew what, but in learning what we, as a species, are truly capable of when we look at the world not as a territory to be owned, but as a home to be understood in concert with the stars. The beauty of this mystery is that it invites you to participate directly. You do not need a satellite or a doctorate to begin looking for the threads of this ancient web in your own landscape. Start with a detailed topographic map of your local region, the kind that shows not just roads but the subtle contours of the land itself. Look for the old places, the sites that have held meaning for generations. An ancient parish church, often built on much older sacred ground, might be your first clue. A weathered standing stone in a farmer's field, a forgotten burial mound on a hilltop, even the etymology of a local place name can point to a site of ancient significance. These are the potential markers left by those who came before, the local nodes in a wider network. With a simple compass and a clear horizon, you can begin your own survey. Visit one of these sites at dawn on the summer solstice or sunset on the winter solstice. Observe where the light falls. Does the main axis of the old church align with the rising sun on that special day? Does a path between two local stones point directly toward a distinctive, distant hill that has always been considered a local landmark? Modern astronomy apps make this even more accessible, allowing you to simulate the sky from any location on any date in history to see if the builders were targeting a specific star. Next, measure the distances between these local sites. Do they form simple, clean ratios? Is the distance from the old church to the stone circle exactly twice the distance from the stone circle to the ancient well? These simple mathematical relationships are the fingerprints of intentional design. Look for alignments that incorporate the natural world, for the ancients saw no separation between their architecture and the living landscape. Does a line from the burial mound pass over a spring before striking the peak of a mountain? Does the local river bend to touch three ancient sites before flowing on? This hands-on exploration does more than test a theory. It changes your relationship with the land beneath your feet. You begin to see the countryside not as a random collection of hills and fields, but as a carefully composed document, a palimpsest of meaning. You might discover that the road you drive every day follows a ley line documented by local historians, or that the hill behind your town is the focal point for several ancient sightlines. This makes the grand, abstract theory of a global coordinate system suddenly tangible and personal. It suggests that the great tapestry of aligned wonders is not just woven from pyramids and temples, but from countless local threads, from the humble village stone to the grand cathedral, all part of a shared human impulse to map the sacred onto the world. Your own local history, your own hometown, might be quietly participating in this planetary conversation, a silent witness on a line that points toward a distant star or a mountain 1,000 miles away. True archaeology is not confined to exotic deserts or deep jungles. It is waiting in the landscape just outside your door, inviting you to read a story written in stone, earth, and alignment. Every year, the map of the ancient world grows, with each discovery, from a forgotten temple complex in the Guatemalan jungle to a submerged structure off the coast of Japan. Another potential data point is added to the global puzzle. The investigation has moved far beyond speculation into a new era of high-tech inquiry, where the tools of modern physics are beginning to peer through solid stone. Techniques like muon tomography, which uses cosmic rays to create three-dimensional images of dense structures, are now revealing hidden chambers and internal voids within the Great Pyramid and other monuments, suggesting we have not yet found all their secrets. Simultaneously, artificial intelligence algorithms are being set to work on the vast datasets of global alignments, searching for subtle, non-human patterns in the numbers that might escape our own pattern-seeking brains. This fusion of cutting-edge technology and ancient enigma is opening frontiers we could scarcely have imagined a generation ago. Yet, for every technological leap forward, fundamental human questions persist, anchoring the mystery in profound wonder. Was there a single, central source for this geodetic knowledge? A mother culture whose explorers and surveyors seeded this understanding across the globe? Or does the evidence point towards something even more remarkable, the independent, convergent discovery of cosmic harmony by disparate cultures who then shared and refined this knowledge through later contact? We must also ask about core purpose. Was this system primarily a practical tool for global navigation and territorial mapping, a sacred calendar to harmonize human ritual with celestial cycles, or a spiritual technology designed to tap into the Earth's own energies? The most compelling answer is likely all of the above, a holistic science that made no distinction between the practical, the astronomical, and the divine. Perhaps the greatest hope for a definitive answer lies in finding a kind of Rosetta Stone for this geometric language. Could a sealed library, perhaps still hidden beneath the sands of Egypt or the jungles of Mesoamerica, hold a manual? Might a previously misunderstood artifact, like a more complete Antikythera mechanism, be found with inscriptions that directly link its gear ratios to specific longitudes and latitudes? The future of this quest depends not on a single brilliant mind, but on a new kind of collaboration. It requires archaeologists to listen to astrophysicists, data scientists to work with historians of religion, and geologists to compare notes with experts in traditional indigenous knowledge. This interdisciplinary bridge is where the next great breakthroughs will occur. Each answered question, each confirmed alignment, inevitably reveals 10 more, weaving an ever more complex and beautiful tapestry. This ensures that the grandest mystery of our shared past, the silent, stone-written code of our ancestors, remains one of humanity's most enduring and exciting adventures, a conversation between the past and the future that is only just beginning. The silent lines drawn across our planet form a map of forgotten genius. From the sands of Giza to the jungles of the Amazon, we have traced a web of latitude and longitude connecting wonders that should not speak to one another. This evidence, woven from solstice alignments, harmonic distances, and shared mathematical constants, presents a portrait of our ancestors that challenges every textbook. They were not primitive people groping in the dark. They were profound astronomers who read the slow clockwork of the stars, meticulous mathematicians who encoded pi and phi into stone, and master surveyors who understood the spherical Earth with a clarity that startles our modern assumptions. Their ultimate goal was not merely to build but to harmonize. In their worldview, a temple was a bridge between earth and sky, and by placing it with celestial precision, they believed they could align human destiny with cosmic order. The legacy they left is not in written scrolls that can burn, but in the permanent language of landscape, a code of alignment we are only now, with satellites and software, beginning to stammeringly decipher. The debate over its origin continues fiercely. Does this pattern point to a single, lost source civilization whose explorers seeded this knowledge? Does it show the slow, beautiful diffusion of ideas across millennia of cultural exchange? Or does it reveal something about human consciousness itself, an innate, universal genius for recognizing harmony? A genius that flowered independently across the globe whenever people looked deeply at the stars and their own place within the turning world. Whatever the source, the conclusion is inescapable. The ancient world was not a collection of isolated cultures whispering into the void. It was a conversation. It was far more interconnected, intentional, and sophisticated than our standard histories have ever allowed. This realization is an invitation. It asks you to look at an old map with entirely new eyes, to see the familiar countryside not as random hills and fields, but as a page from a global manuscript. It encourages you to question the tidy timelines we have been given and to marvel, above all, at the enduring human spirit, a spirit that sought to measure the heavens, to inscribe its understanding onto the very body of the earth, and to send a message in stone across the ages to us, right here, right now. If this journey through time and alignment has sparked your curiosity, there are countless more historical mysteries waiting to be explored. Consider subscribing for more deep dives into the hidden layers of our past. And we would truly love to hear your perspective down in the comments. Of all the global connections we have discussed, which one intrigues you?